Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we will start with section 1.4 with the title Algebraic Solution of Simultaneous Linear Equations. So the objectives of this topic are, at the end of this section you should be able to solve a system of two simultaneous linear equations and two unknowns using elimination method. Detect when a system of equations does not have a solution. Detect when a system of equations has infinitely many solutions. So we'll start with the elimination method. So we are going to solve a system of linear equations using a method. It's called the elimination method. So a system of linear equations consists of two or more linear equations. In the elimination method, you either add or subtract the equations to get an equation in one variable. When the coefficients of one variable are opposites, you add the equations to eliminate a variable, and when the coefficients of one variable are equal, you subtract the equations to eliminate a variable. Example, 4x plus 3y equals 11. This is the first equation. The second equation is 2x plus y equals 5. So we need to solve these two equations. Solving the two equations means finding the values of x and y that will satisfy simultaneously, means at the same time, both equations. So we are looking for the values of x and y. If substituted in equation 1, then the left side of equation 1 will be equivalent to 11. And if the same values of x and y are substituted now in the equation number 2, the left side of this equation number 2 will be equivalent to 5. This is the meaning of simultaneous solution of linear equation. So to find the values of x and y, select variable to be eliminated. For example, we decide to eliminate x, the variable x. Now, the coefficients of x in both equations should be equal. To eliminate x by subtraction or addition of the two equations, the coefficients of x in equation 1 and equation 2 should be equal. Now, since these two coefficients are not equal, then we have to make them equivalent to each other. Then these two can be changed to 4 if we multiply by 2. So we have to use the multiplication here to change 2 to 4. So if we multiply equation 2 by 2, then we will get 2 multiplied by the whole equation. This is the property of the equation. We have to multiply each side of the equation by 2. So expand this bracket, then 2 times 2x is 4x, 2 times y is 2y, and 2 times 5 is 10. So this equation number 3 actually is derived from equation number 2 after we multiply it by 2. Both of them are the same equations. Both of them have the same relation between the left and right sides, except that the numbers here are different, but both of equation 2 and equation 3 are the same, because we multiplied the equation by 2 to obtain equation number 3. Now, this equation number 1 and this equation number 3, both coefficients of x are the same. Now, let's subtract equation 3 from equation 1. So if you subtract here, 4x minus 4x is 0, 3y minus 2y is 1y, equals 11 minus 10 is 1. So by eliminating the x term, we found the value of y. So the value of y here is 1. So y equals 1. Now, to determine the value of x, we have to take this number, y equals 1, and substitute it now either in equation 1 or equation 2 or even equation 3. So let's substitute y by 1 in equation 1. Then we will get 4x plus, instead of y, I'm going to place it to 1. So 4x plus 3 times 1 equals 11. And then 4x plus 3 equals 11. Now subtract 3 from both sides of this equation. We will get 4x equals to 11. And then you divide by 4, you will get x equals to 2. Okay? So this is the value of x, which is 2. So we managed to find both value, the value of y equals to 1 and the value of x equals to 2. Okay? So the solution, or the set of solutions of this equation are x equals 2 and y equals 1. The second example here, solve the system of equations 3x plus 2y equals 2, and the second equation is minus 2x plus y equals 1. Now let's also eliminate x. Well, if we eliminate y may be easier, but let's eliminate x. So to eliminate x, we have to make these two coefficients similar to each other, 3 and 2. So there's no number, if we multiply 2 with, we will get a 3. So in this case, we have to multiply both equations, the first equation by a number, the second equation by a number, to get the same coefficients of x. So the best way to do is you multiply the first equation by 2 and you multiply the second equation by 3. Okay, you swap the coefficients here. So the first equation will be multiplied by 2. You will get 2 times 3x plus 2y equals 2. The whole equation. Multiply 2 by the whole equation, you will get equation number 3. Okay, 6x plus 4y equals 4. And then you multiply the second equation by 3. The whole equation by 3, you will get minus 6 plus 3y equals 3. Notice here the coefficient of x in the equation number 3 is the same as the coefficient of x in equation number 4. The signs are different. Since the signs are different, so we have to add the equation 3 and 4. So by adding equation number 3 and 4, what you will get here, if you add these two equations, you add the two equations, then 6x minus 6x is 0, 4y plus 3y is 7y equals to 7. And then by dividing both sides by 7, you will get y equals to 1. So you will get y equals to 1. Now to find the value of x, you have to take this y equals 1 and substitute in the first or the second equation, you will get x. So this is y equals 1. Now you substitute y equals 1 in the first equation, 3x plus 2 times 1 equals 2. And you solve this equation, you will get the value of x as 0. Then the solution of this system of linear equations is x equals 0 and y equals to 1. So this is the way we use the elimination method. Excuse me. Here we have some practice problems. Use the elimination method to solve the following systems of linear equations. So we can apply the same techniques that we used in solving the previous two examples, and then we can get the solution of these two equations. Try these questions at home. We can discuss the solution of them further during our class if you cannot solve them. Here we have one more example. Solve the system of equations. Now we are going to use also the elimination method by eliminating x. So if you multiply the first equation by 2, then we will get 2x minus 4y equals 2. This is the first equation after multiplying by 2, and this is the second equation. We write it as it is. Now if we subtract both equations, because these two coefficients have the same sign, positive and positive, so to eliminate them we have to subtract. So if we subtract equation 2 from equation 1, then we will get 0, we will get 0, and we will get 5. So 0 plus 0 is 0. So in the left side we have 0, and the right side we have 5. And this mathematically cannot be accepted. Doesn't make sense, because 0 is not equivalent to 5, which means that there is no solution for this system of linear equation. So if the elimination method gives us a nonsense equation, 0 equals 5 or 0 equals any other number, which doesn't make sense, then we will say no solution of this linear equation. So this is a special case if there is no solution of these linear equations. The other special case is demonstrated in this example. Let's solve these equations. 2x minus 4y equals 1 and 4x minus 10y equals 5 over 2. Now if we multiply the first equation by 5 and the second equation by 2, then we will get these two equations where the coefficients of x are the same. So multiply equation 1 by 5, you will get 10x minus 20y equals 5, and multiply equation 2 by 2, you will get 10x minus 20y equals to 5. Now by subtracting both equations, then on the left side we have 0, and on the right side we have 0. 0 is equivalent to 0. That's right. This makes sense. So in this case, if we got 0 equals 0, then the system of linear equations has infinitely many solutions. Infinitely many solutions means unlimited solutions, many solutions. So any point you choose for x and for y, any value you choose for x, and then you find the corresponding value of y from the first equation, the same set of values for x and y will satisfy the second equation. So that's why these two equations can be satisfied by many solutions. We say infinite number of solutions. So there are two special cases: if 0 equals a number or 0 equals 0. If 0 equals a number, then there is no solution. If 0 equals 0, then there is an infinite number of solutions. Here we have some practice problems. Again, you have to try these at home, and we can discuss further in our class. I think that's it for today, and I will see you during the class, inshallah. Bye bye. Assalamu alaikum.